So hello everyone, welcome to our new video. Today we are going to learn about dynamic memory allocation. So dynamic memory allocation, what it is actually. So whenever we are creating any variables or any objects, then there are two different ways of creating memory. One is static and the other one is dynamic. Regularly, whatever the variables we create for integers, for float, for an array or whatever may it be, all those are created in a static way. So they are called as static memory allocation. But here today we are going to talk about dynamic memory allocation. So now this dynamic memory allocation, what it is? Suppose if we don't know how much memory is actually required. Suppose if you want to take some numbers from the user and give the user the sum of all those numbers. Now here we don't know how many numbers is the user going to enter. So suppose just a random number 100, I created a array of 100 integers. Done. Now suppose if a user comes and the user wants to enter 101 numbers. Now in that case 100 till 100 it was okay, but one extra number I cannot store that number. So what to do now? We don't have any idea. Second thing, suppose if the user wants to enter only 5 numbers. We have created a memory for 100 integers, but the user is only willing to enter 5 numbers. So in that case, what are we going to do? We can't do anything. I created some memory, some space for 100 integer variables. So in all these different type of cases, similarly whenever we are dealing with linked list, we cannot just randomly create a linked list of something n size. Their linked list is about creating a new node every time. We don't know how many nodes a user wants. So there again comes the need for dynamic memory allocation, that creating a node and then storing the address of that node somewhere to any previously existing node. So here in C programming allows us for 4 different functions for dynamic memory allocation. Now those functions are malloc, calloc, realloc and free. The first one we have malloc. Now this malloc function, it takes input parameter as the size, how much size of memory is required. Now whatever the size we provide it with, it creates a variable of that memory size and returns a void pointer of that memory. Similarly, calloc creates a memory and it also assigns some value into those memory. Third one we have realloc. Suppose we have created a variable, we have a fixed size. Now later on the user wants to change the size. Maybe the user wants to increase the size or maybe the user wants to decrease the size. So in that case we can use a realloc function. The realloc function takes 2 parameters. The first one is the pointer, the address of the previously allocated memory, and the second one is the new size, and the last function is free. Suppose we have created a memory, we have used that memory, now later on we don't have any use of that memory, then it is very important and very necessary to release the memory whenever we are using anything. So this is it only for the theory part. So now I will write a program and show you how we can use the malloc function in C language. So here, now what is the first line here? We write here as hash include stdio.h. We have the main function, return 0. So here, let's take the same example and let's take some input from the user. And let's first ask the user that how many numbers the user wants to enter here. So printf enter the number of values. Whatever the user enters, we need an integer variable n. Scanf %d %n. Now we want to use the malloc function. The malloc function, it does not exist in the standard input output library. So here we need to include another library here, stdlib, standard library. Now inside this we have the malloc function. So malloc, as I said, it takes the size, how much size is required. So here the user wants to enter integer values. So how many integers? There are n integers. What is the size of an integer variable? So we are going to use the size of function, pass the integer value here. Done. Now, as I said that it returns a pointer. It returns a void pointer. So I have created a pointer variable here. Now, whatever it returns, I am going to store it in the pointer variable, and also we have to convert this memory into a integer one, and it is done. Now we are going to ask the user for the inputs, that what are the input values here. So here we don't know what is the number of elements. Whatever it is, the user will be entering and it will be stored in the variable n. Now using this variable n, we are going to execute a for loop, and at every iteration we will take the input from the user as well as store it in the sum variable. So I have this sum variable here which is equal to 0. Now here comes the first thing, take the input here, scanf %d, comma. Now here either we have to write here as star ptr plus I, or also instead of this we can write here as ptr of I, because this is going to behave as a pointer variable, and at every iteration sum plus equal to ptr of I. So this for loop will take all the input from the user, and as well as it will do the sum, and it is going to store the value in the sum variable here. So now here let's print the sum here. So sum is %d, comma, replace this with the sum variable, and it is done. Let's execute this and see how it works. So let's say if I want to enter 5 values here, I have given the number of values 5. Now I have to enter all the values 6, 8, 7, 2 and 1. So if I want to check the sum here I have 10 plus 14, total I have 24. So it is giving me the sum here as 24. It is working perfect. Now two things I have not done yet. Now what are those? The first thing, whenever we are requesting for some memory, now if that amount of memory is not available in our system, then it is going to return a null pointer. Now if it returns a null value there, then it is not going to do any operations. Whatever we have written here, taking the input, storing it in the array, and then finding the sum, it is not going to work there. So here, every time when we request some for any memory, then we have to check here if whatever be the name of the pointer, if ptr equal to null, then in that case give an instruction to the user as unable to allocate memory. Done. Return 0 over, because why have I written here is return 0, because we know that the memory is not allocated, and there is and doing all these operations is of no use in this case. And at last, when we have used all the memory here, so here use the free function, pass the pointer variable, and it is done. So this is it about the malloc function. Let's execute. Let's enter the value. Number of values here is 7. The values are 7, 4, 1, 2, 5, 8, and let's say 9. Done. Now if I check the sum, here we have 10, 20, 20, 20, 20 plus 16, we have 36 here. So the sum it is giving us here as 36. So this is it. So this is it about the malloc function. In the next couple of days, we are going to record videos on the other functions and we are going to upload them. So please stay tuned, and to get the notification, please don't forget to subscribe to our channel and don't forget to press the bell icon so that you get a notification whenever we upload a new video. Now if you have any doubts, please give us a comment in the comment section. We will definitely get back to you. And if you have liked the video, please hit the like button because that gives us a motivation to make new videos every time. So thank you very much. Keep learning.